the last measure of position that we have in our syllabus, which is z-score. Z-score is commonly related to normal distribution. So, in other words, to use z-score, you need to make sure that your data, right, is normal, right? If you are drawing a histogram, it should be, the shape should be somewhat normal, like this, right? So when you, even though it is not perfect, but you should see, sort of normal shape. So then you can use z-score. If you are looking at box plot, the box plot should be, right, somewhat symmetry, the left and right. Then you can use z-score. So basically, z-score is can only be used when your data is normal. Okay, so what is z-score? Z-score tells how many standard deviation of a data that is above or below the mean. Okay, now the main usage of z-score is to standardize your score. In other words, by using z-score, we can compare, right? Previously, when we compare something, we should compare, as an English idiom say, apple to apple. You can't compare things that is different, right? In terms of data, we can actually compare things that is different, right? By standardizing it using z-score, given that your data is normal, right? So we can compare apple to strawberry, yeah, given that your data is normal. Okay, let's see how to do that. So this is the formula you have for sample and for population. So the formula is similar actually. It is your data, subtract with mean over standard deviation. That is how to calculate it. In terms of sample, it is x minus x bar over s, right? They are the same, mean and standard deviation. It's just that this is a statistic, right? Remember the terms? The statistic, where you obtain it from a sample. As for this, we have mu, which is also mean, and sigma, which is also standard deviation. But now for population, and this denote the parameter. Okay, so let's try to use it. Let's go straight to this. Let's say we want to compare a test score of mathematics and statistics. Okay, mathematics and statistics. Okay, now I want to make things more interesting. Let's try to change this. Let's say not 72. Let's try to make it 60. Right? Let's try to make it 60. Okay, your score for mathematics is 38, which is, when you think of it, that is fail. Worse, right? You start to think of it, yeah, the score is low compared to statistics, which is 60, which is higher. You get B. So by right, you're going to say that, okay, I'm good at statistics. I'm not good in mathematics. That is how you conclude the self. But let's see in other other kind of view. So let's try to see which is actually higher in terms of the score of that class. What can you consider of your mathematics score and statistics score? Whether your mathematics is really bad in your class. You in your class having a bad mathematics grade compared to your friend, or maybe statistics is bad compared to your friend, or better compared to your friend. So how to do that? You should First, get the mean x bar and also standard deviation of the score for mathematics and statistics for your class. Right, so basically for this one, they get 40 for the mean, the average score of mathematics in your class, and with 5 standard deviation. Okay, as for statistic, 75, mean is 75 with 10 standard deviation, and we assume that the score in your class, the score for mathematics and statistics in your class, distribution is normal. Okay, so let's say that this is the distribution of mathematics and statistics, right? One is mathematics, right? This is for math, and this is for stat. Okay, so let's try to fill in the information that we have. Now, the mean for mathematics score is 40, meaning that and the distribution is normal, right? So normal distribution is like this kind of shape, so the mean should be in the middle here. So 40, I put 40 here, okay, as the mean, with 5 for the standard deviation, meaning that the first standard deviation is 40 plus minus 5, remember? So 40 plus 40 minus 5 is 35. You have 35, and 40 plus 5 is 45. Right, this is the first standard deviation. So we can say that, right, this is the for the first standard deviation, right, the score is between 35 to 45, right, 35 to 45. I'm revising the measure of central tendency. Okay, now for the second standard deviation, for the second standard deviation, right, 40 plus minus 2 times 5. So we get, for the second standard deviation here, it should be 30 and 50. Alright, so the range here is the range is from 40 to 50, for 30 to 50. This is the range for second standard deviation. As for the third standard deviation, right, for the third standard deviation, we get 25 and 55. Okay, so let's do the same with stat. So there you have it. Now let's say that in terms of position, mathematics, right, you get 38. You try to put it here, 38 maybe around this point, right? This is where you is. As for statistic, I'm saying let's go for 60, right? 60 is around here. So what can you say about this? Which is better? Even though your statistics score is 60, compared to the class, is you actually below mean, less than 50% of your friends, meaning that compared to relative to the score that your friend get, your score here is low. As for math, you should be happy maybe, because your score is almost around the mean, right? Meaning that you are no less compared to your friend, even though you score 38. There is around 50% of others that is, as bad as you. So basically, it's not maybe not your problem. Maybe the problem lies on the test itself, maybe on the one who actually teach you, right? So that is how you see it. Now, without drawing like this, how can we do the same comparison? By using z-score. So we conduct the formula of z-score as you can see here, right? This is the calculation for mathematics. X minus x bar over mean, you get negative 0.4. By the way, when you calculating a z-score, right? By default, this chart, right? The value, the x value here at the bottom of this chart will change to 0 and 1. So this is the z-score chart, right? The value will become 0 and 1, right? Negative 1, 1, negative 2, 2, negative 3, 3. They are still the same 1 standard deviation, 2 standard deviation, and 3 standard deviation, but it changed to 0 and 1. Why? How can they change it like that? Right? Simply use this value, right? Put it in the formula and you will see what I mean. For example, 40 here is mean, right? And so basically, if x is 40, 40 minus 40 over 5, you will get 0. Right? For this one is 75. So 75 over the mean, which is also 75, 75 over 75, 75 minus 75 over the standard deviation of 10, you will get 0. So it doesn't matter what kind of chart, what kind of data that you have, when you standardize it, all of them will become 0 and 1s like this. And just and when it is like that, we can say that they are having that they can sit on the same chart. So instead of compare it on the different chart like this, right, we can calculate it, right, and compare it equally. So just now we have the score of mathematics 38, negative 0.4. If we try to plot it here, negative 0.4 is, this is 0.5, and negative 0.4 is around here, right? This is negative 0.4. Sorry, this is where negative 0.4 should be. Okay, try to put different color. Negative 0.4. This is where it should be, right? Okay, and for statistic, let's change this. This is not 72, 60, right? Put it 60 just now. 60 minus 75 over 10. What do you get? Negative 1.5. So negative 1.5 is here. Okay, so basically, if you want to compare it, relative your score of mathematics and statistics, okay, we can say that, right, your score of mathematics, the mathematics score is better compared to statistics in terms of the whole class, even though by right this score is lower compared to this score. So that is what z-score is. We standardizing a score across different units, so that later we can be under the same chart, right? So that is z-score. Okay, so in the next video we can talk a bit on outliers and its effect. Okay, thank you.